Hello and welcome guys to my YouTube channel. In today's video, we will be solving a bunch of mixed exercises on compound interest, simple interest, and appreciation and depreciation, so you can build confidence in dealing with all kinds of mixed questions. You should aim to pause the video and try to solve the question on your own first and then check the solution. Okay, let's take a look at question 1. You invest $3,000 in a savings account that offers a 3% simple interest rate for the first 2 years, okay, and then changes to 4.5% compound interest for the next 3 years. So what will be the total value of the investment at the end of 5 years? So we essentially are going to be investing for 5 years. The first 2 years, we will be having a rate of 3%, and the amount is 3,000. And for the next 3 years, we will have a rate of 4.5%, and it's compound interest. Okay. Now, the way to solve this question is that at first we're going to find the amount of money that I will have after 2 years, right? And this will be the amount that will go into the compound interest. So let's start with that. So we're dealing with simple interest, 2 years, and the rate is 3%, and the amount is 3,000. So we're going to go ahead and write the simple interest. So we're going to firstly find the interest, which is equal to P multiplied by R over 100 multiplied by T. And P is the principal amount multiplied by R, which is 3 over 100 multiplied by the time, which is 2 years. And we're gonna go ahead and plug those numbers on our calculator, and we get $180. So this is the interest that I will be receiving from the first 2 years. So the amount of money, the total amount, will be the original, which is 3,000 plus 180, and we get 3,180. So at the end of 2 years, we have 3,180. Now, so when we begin the third year, and then the fourth and the fifth, for the next 3 years, we will be dealing with compound interest, okay? So we're dealing with compound interest now, where the rate will be 4.5, and the years will be, or like the time is 3 years, and the principal amount will be 3,180, okay? It's not going to be 3,000 because when you're dealing with such an investment, you have your money at first is 3,000, and then over the period of 2 years, we have 3,180. Now, when the compound interest starts right here, it will start with this amount, okay? This is the amount that it will start with. This is the principal amount for the compound interest, which will go on for 3 years at a rate of 4.5, okay? So we want to know the total value of the investment at the end of 5 years. So we're going to go ahead and say, write down the compound interest rule, which is basically the final amount is equal to the principal amount multiplied by 1 plus R over 100 to the power of n. And we're going to go ahead and plug in the principal, which is 3,180 into 1 plus R, which is 4.5 over 100 to the power of 3. All right. 3,180. You can just go ahead and plug this on the calculator. Plus 4.5 over 100 to the power of 3. And we get 3,000 628.9. Now the question did not specify a unit of round, so I'm gonna go ahead and let me just fix this. I'm going to round this to 3 significant figures, so it's gonna be 3,630. Okay, I hope this makes sense. Moving on to the next question. All right. The population of a town was 150,000 in the year 2015. Okay. If the population increases by 4% each year, what will be the population in 2022? Assume the growth rate remains constant. Okay, so here's the thing. Firstly, you need to understand that this can be solved based on the appreciation or the compound interest rule. Okay, and the reason for that is because every year the population increases by 4%. This 4% is based on the current population. Okay, so if let's say right now your population is 150,000, okay, in the next year you're supposed to increase by 4%. All right, 4% of the 150,000. So if you want to increase by 4%, this will be an addition of 6,000 people. So you end up with 156,000 people, right? In the next year, you will increase 4% based on your current population, which is 156,000, right? So this will be an increase of 6,240 people. So basically, you will end up with around 162,240, right? So as you can see, the increase is based on the population now, so it's changing, okay? So this is a perfect model for basically appreciation or compound interest, really, okay? So whenever you're dealing with population increase or decrease, you're dealing with appreciation. So for appreciation, we're going to go ahead and say that we have firstly the initial, which is this right here. This is the principal amount. We had 150,000, right? And every year the population increases by 4%. This is R right here. R is equal to 4. What will be the population in 2022? So I want to know the new population, which is the final amount, or the current. So this is what we want to know. And now I do know that this is between the year 2015 and the year 2022. So we actually do know the time N, right? It will be basically 2022 minus 2015, which is equal to 7. So 7 years have passed. So now I can know what the population will be in 2022 by simply using the appreciation rule, where the current or the new is equal to the principal multiplied by 1 plus r over 100 to the power of n. And the current right now is unknown, which is in 2022. We want to know it. The previous or the principal is 150,000 multiplied by 1 plus 4 over 100 to the power of n, which is 7. So this is fairly straightforward. You just plug in the right-hand side on your calculator and you should get the answer is the current population is equal to 197,389. Now you're going to get like 0.7669, right? But those decimals right here, they don't make sense. That means that after 7 years, like in 2022, you will have 197,389 people and 0.7 persons. And that doesn't make sense at all. You can't have 0.7 person. You either have them or don't have them. So basically this right here, the decimals right here don't mean anything. You can just omit them, right? You don't round up or anything, you just omit them. In any case, we are going to give the answer to three significant figures as usual. This is the first, this is the second, this is the third, so 197,000. This will be the population in 2022. Okay, so let's move on to question 3. An antique vase was purchased for $1,200 and appreciated by 5% annually for the first 3 years. Okay. However, due to a market downturn, it depreciated by 7% per year over the next 2 years. What is the current value of the vase after 5 years? So this is again another question where you have different rates and you have appreciation and depreciation at the same time. So we know that we had the vase at first and it cost us $1,200, and we know that over time it appreciated by 5%, right? And for 3 years. And then, it reached a certain price, which let's call the new price right now, right? And then it depreciated. So this right here, this was appreciation, okay? And now it depreciated by 7% for the next 2 years until we reach the final price today, okay? So again, in order to solve this scenario, we firstly need to find out the middle price right here, and then depreciate this price to find the final price. So we're going to go ahead and firstly say that the appreciation rule, we're going to write it down. So the current is equal to the principal multiplied by 1, and we're going to use a plus, because this is appreciation right now, r over 100 to the power of n. And so the current price is equal to 1,200 multiplied by 1 plus 5 over 100 to the power of 3. And again, this is fairly straightforward. We're going to go ahead and plug it on the calculator, plug our numbers, and we get that the current price is 1,389.15. Okay, so this is the price of the vase after it appreciated by 5% for 3 years. So it's basically this box right here. This is the price right here. I'm going to go ahead and write it down. So 1,389.15, and we must use it accurately. Okay, now for the next 2 years, it depreciated by 7%. Okay, so what did depreciate? The value of the vase right here. Okay, so now we will use that information to find the final price of the vase, which is what the question is asking for. So now basically we're going to go ahead and write that current price is equal to the original one multiplied by 1. And we're going to use a minus right here because this is depreciation to the power of n. So the current or the final price is equal to the original one, which is in this case 1,389.15 multiplied by 1 minus 7 over 100, which is the rate, to the power of 2 because this happened over 2 years. And now I'm gonna go ahead and plug these numbers on my calculator. 1 minus 7 over 100 to the power of 2. And so we get 1,201.4 and a bunch of more decimals. Rounded to 3 significant figures, this will be 1,200 because this is the first, this is the second, this is the third, and it will not get rounded up because we have a 1, and this will just turn to a 0. So this is the final answer. So essentially the vase actually returned to its original value over the course of 5 years. All right, I hope this made sense. Let's take a look at the next question. All right, so such types of questions are fairly common, and you will deal with them a lot because you will be given two options to invest your money in, and you will be asked which is a better investment. So you have 10,000 to invest and are considering two options. Option A, you invest in a savings account with 3% annual compound interest for 5 years. Option B, you invest in a stock market that appreciates by 7% annually, but is expected to depreciate by 5% in the last year due to market volatility. Which option will give you more money after 5 years? The only and best way to solve these scenarios is by calculating how much money would you make in option A and how much money would you make in option B and choosing what is best for you. So I'm gonna go ahead and start solving for the option A scenario. So for option A, we're dealing with a principal amount of $10,000, which is the amount you want to invest. We're dealing with compound interest where the interest rate is 3%, and we're gonna be investing for 5 years. So N is equal to 5. All right, so and of course I want to know the final amount of money I will have. So basically the final amount. So now I'm going to go ahead and write the rule for compound interest, which is A, final amount or the total amount is equal to the principal amount multiplied by 1 plus R over 100 to the power of N. And A is equal to 10,000 multiplied by 1 plus 3 over 100 to the power of 5. And now we're gonna get those numbers on our calculator, and we get that the total amount after 5 years will be 11,593. I will be dealing with this to the nearest decimal, nearest dollar. All right, now, so this is for option A. That's it, we're done with option A. So we know that after 5 years with option A, we will be receiving, or like, not receiving, we will have this total amount of money right here, okay? Now, for option B, it's a little bit more complicated. So we know that it's going to appreciate by 7%, okay? But in the last year, it will depreciate by 5%. Now we're dealing with a total of 5 years. So we're talking that the first 4 years will be a scenario of appreciation, right? And at a rate of 7%. And the initial amount or the principal amount, let's write this is equal to R. And since this is R, we're going to remove the percentage right here. Okay, and an initial amount or a principal amount of, how much was it? Oh, 10,000, right? Now, for the final year, which is just going to be 1 year, we're going to be dealing with depreciation. And the depreciation rate is 5%. And the principal amount for this will actually be the final amount after the appreciation, right? So again, this is the same as the previous question. At the end of the 4 years, I will have a certain amount of money. It's the final amount for this. And that will be the initial amount for the new depreciation scenario, okay? So now we're going to go ahead and solve this. So firstly, we have the data for appreciation right here. I'm going to go ahead and write the appreciation rule, which is A is equal to the principal multiplied by 1 plus R over 100 to the power of N. And I know that the amount is going to be equal to 10,000, which is the principal amount, multiplied by 1 plus 7 over 100 to the power of 4, because it will be for 4 years, okay? Now we're going to go ahead and write those numbers down on our calculator. And we will get, all right, so we will have 13,107.9601. Since this is not the final answer, you should keep it fully accurate. All right, so now, so this, again, what is this? This is the amount in the account, in your investment account, at the end of 4 years. All right. Now, after the 4th year, we have one last year, which is the 5th one. In the 5th one, as we've stated right here, there will be a depreciation by a rate of 5% for 1 year, for exactly 1 year, because it's the last year. So n is equal to 1. Okay. And the principal amount will be the final amount right here. Okay. This is what I was trying to explain right here. This amount right here is the new principal one. Okay. Because the depreciation will happen on this amount. Okay, so we're going to go ahead and write down the rule for depreciation, which is final amount is equal to the principal multiplied by 1, and we're going to use a minus right here because this is depreciation, r over 100 to the power of n. And so the final amount is equal to 13,000, that's the principal, 13,107.9601, use it fully accurately, multiplied by 1 minus 5 over 100 to the power of 1 only. Okay, because n is equal to 1. And now I'm going to go ahead and plug these numbers on the calculator. And this gives us that the final amount for the overall investment will be 12,453. This is like basically my final answer here, so I rounded it to the nearest dollar. All right. So this is the final amount in the option B. So as you can see, option A, at the end of 5 years, you will have 11,593. However, in option B, you will have 12,453. And so we're going to write down that option B gives you more money after 5 years. All right. There is no need to justify it in this case because the calculations are already justifying it. Okay, let's move on to the next exercise. All right. You have $15,000 to invest and are considering 2 different banks. Okay. So for Bank A, you have the option to invest in a savings account that offers 4% annual compound interest for the first 3 years and then drops to 2.5% compound interest for the next 2 years. So it's a total of 5 years. First 3 years, 4% compound interest. Next 2 years will be 2.5% compound interest. As for Bank B, invest in a diversified portfolio where the investment is expected to appreciate by 6% annually for the first 2 years. So we have an appreciation of 6% for the first 2 years. However, due to market uncertainty, the portfolio will depreciate by 4% over the final next 3 years. Okay. So calculate the difference between the interests received from each bank. Okay, so yeah, this question is going to need a lot of space. So again, the perfect way to solve this is firstly to find the total amount you will have if you invest in Bank A at the end of 5 years. So for Bank A, again, so we're dealing with 2 different chunks of investment. So firstly, you're going to have that for the first 3 years, n is equal to 3, we will be investing at a rate of 4% compound interest. And the principal amount we're investing is 15,000. And we want to find the final amount. All right. Now, for the next 2 years, n is equal to 2, we're going to be investing basically at a rate of 2.5%, but it's also compound, so it's the exact same. And we want to find the final amount for it, but the principal amount right here will be the final amount from the first 3 years, okay? Because like we've mentioned in the previous questions, the final amount will be the new principal in the new scenario, all right? So now I'm going to go ahead and find the final amount. So we're going to write down the compound interest rule, which is amount is equal to the principal multiplied by 1 plus r over 100 to the power of n. And so A is equal to 15,000 multiplied by 1 plus 4 over 100 to the power of 3 years. I'm going to go ahead and plug those numbers on the calculator. And we get that the amount is equal to 16,872.96. I will keep everything accurate right now because the final answer requires us to find the difference between the interests. Okay, and so this is the amount we have. This is the final amount. After 3 years. Right? Now, based on this amount, for the next 2 years, we will be gaining 2.5% in compound interest. And now we want to find the final amount for the overall investment. So I'm going to go ahead and write that A is equal to the principal amount multiplied by 1 plus r over 100 to the power of n. And the amount is going to be equal to, so the principal right now is 16,872.96. It's the final amount from the 3 years. It will go in as the principal in the next 2 years. 1 plus the rate is 2.5 over 100 to the power of 2 because we're dealing with 2 years now. So I'm going to go ahead and plug these numbers on the calculator. And we get that the final amount is 17,727.1536. Okay, so this is the final amount of money that you will have after 5 years in Bank A. Okay, now let's calculate for Bank B. So in Bank B, we're being asked invest in a diversified portfolio where the investment is expected to appreciate by 6% annually for the first 2 years, but it will depreciate by 4% over the next 3 years. All right, so let's draw a quick scenario. So Bank B. So we're going to be dealing with firstly 2 different scenarios right here. At first, our investment will be appreciating, and then we'll have depreciation. And the appreciation, it will appreciate firstly by 6% for the first 2 years, so over the course of 2 years. And the principal amount is basically, it's the same amount right here. It's 15,000. This is the money that you have. So it's going to be 15,000. And so we want to find the final amount after this appreciation period, okay? Now, for the next 3 years, we will be depreciating by 4%. So r is equal to 4 and n is equal to 3. And the principal amount for this depreciation, it's the same thing. It's going to be the final amount from the appreciation scenario. Okay, this is the connecting point. And we want to find the final amount overall for the total 5 years. Let me just erase this. Okay. So now let's solve. So firstly, we're gonna find the appreciation. So total amount is equal to the principal multiplied by 1 plus r over 100 to the power of n. And so amount is equal to 15,000 multiplied by 1 plus 6 over 100 to the power of 2. And I'm gonna go ahead and plug these numbers on the calculator. So we get that the amount is equal to 16,854. So this is the amount at after 2 years, okay? Now for the next 3 years, we'll be having a depreciation, as you can see here, and the principal will be this. This is the principal for the next period of time. So now I'm gonna write the depreciation law. So amount is equal to principal multiplied by 1, and this is just gonna be a minus instead of a plus because this is depreciation to the power of n. So the final amount will be the previous or the principal amount, which is 16,854 multiplied by 1 minus 4 over 100 to the power of n, which is 3 years. And I'm going to go ahead and plug these numbers on the calculator. Okay, so we get that the amount is equal to 14,911.34054. Okay, so you can tell that investing in bank A will be better for you. But that's not what the question is asking. We're just being asked to calculate the difference between the interest received from each bank. So to find that, we can just go ahead and subtract those two numbers. So the difference will be 17,727.1536 minus 14,911.34054. And I'm gonna go ahead and plug these numbers on the calculator. The final answer, rounded to 3 significant figures, will be 2,820. This is the final answer. Okay, moving on to question 6. A piece of machinery was purchased for $50,000 and depreciated by 15,000 over 3 years. Calculate the annual depreciation rate. Okay, so we're dealing with a depreciation scenario here. So we know that it was purchased for 50,000, okay? And that it depreciated by 15. So firstly, the original amount is 15, it's 50,000. Right? And over the course of 3 years, so n is equal to 3, we had a depreciation by 15,000. So we know how much it depreciated by. We can use that information to find the final value or the final cost of the machinery by just subtracting. So 50,000 minus 15,000, and this should be equal to 35,000. So this is the final price of the machinery. So now we're being asked to calculate the annual depreciation rate, which is R. So going to go ahead and write down the rule. So the amount is equal to principal multiplied by 1 minus R over 100 to the power of n. And so the final amount is 35,000 is equal to 50,000 multiplied by 1 minus r, which is unknown, over 100 to the power of 3. All right. So the first step to solve such an equation is to divide through by 50,000. And over here, we're just going to have those three, the zeros cancels out, and 35 divided by 50 will simplify to 7 over 10. On the right-hand side, the 50,000 will cancel out, and we get left with 1 minus r over 100 to the power of 3. The next thing to do is to take a cube root to cancel out the 3. All right, so I'm going to go ahead and take a cube root for 7 over 10. On the right-hand side, we'll have 1 minus r over 100. On the left-hand side, we will have 0.887. But as usual, you should keep this accurate, okay? Use it accurately on your calculator. Now, what I'm going to do is I'm going to move this 0.887 by subtracting it from both sides, and I'm going to move this negative r over 100 by adding r over 100, okay? So we're going to get that r over 100 is equal to 1 minus 0.887, and I'm going to go ahead and write on the calculator 1 minus, you should write 1 minus the answer, okay? The accurate version of this. So we get r over 100 is equal to 0.1120 and so on. And then you multiply by 100 to finally get r. So r is equal to, if you multiply by 100, you should be getting 11.209 and so on. Now I will give the final answer rounded to 3 significant figures. It's 11.2%. Okay, let's take a look at question 7. A city's population grows at a constant rate of 3.2% per year. If the population is currently 800,000, in how many years will the population reach 1 million? Okay, so as I've said before, whenever you're dealing with population increasing, you're dealing with appreciation. Okay, it's always appreciation. So firstly, we know that currently the population is 800,000. Okay, so the principal or the original amount is 800,000. And the final amount or the current amount is 1 million. This is the amount that I want to reach. And it's appreciating basically or growing at a rate of 3.2%. And so I want to know how many years would it take to reach 1 million or exceed it. I'm going to go ahead and write the rule. So C is equal to now I'm going to substitute. So 1 million is equal to 800,000 multiplied by 1 plus 3.2 over 100 to the power of n, which is unknown. Now, as you remember, if you've watched the appreciation or the compound interest videos, this right here, when you don't know the n, you should be solving it by trial and error. So let's say I firstly try n is equal to 1. So I will plug in on my calculator 800,000 multiplied by 1 plus 3.2 over 100 to the power of 1. And we get that the amount of people will be 825,600. All right. So I feel like this, if you feel like this is going to be way too slow, you can just go ahead and plug a higher number, like take a really big step. All right. So you can just start trying numbers on your calculator. So for example, I tried up till n equals 6 right now, and it gave me 966,425. So then I'm going to try n is equal to 8. And we finally get 1 million 29,265 people. Okay, so basically during the 8th year. Okay, so how many years will it take to reach? It will take us 8 years. Okay. Okay, let's take a look here. You invest $5,000 in a savings account that offers the following interest rates: 3% in the first year, 4% in the second year, and 2% in the third year. Calculate the total amount in the account after 3 years. And how does this compare to a fixed 3.5 compound interest for the entire period? Okay, so firstly, let's deal with this. So this right here, we wouldn't call it compound interest. You're just talking about increasing your money by 3%, and then increasing your money by 4%, and then increasing it by 2%. So we can just go ahead and use the percentage increase equation, which, by the way, if you notice, so here's the thing. Right here, you will be dealing with only 1 year. Right here is only 1 year. Right here is only 1 year. So even if you wanted to use the compound interest rule, the compound interest will be this rule right here, right? R over 100 to the power of n. You will have n is equal to 1 every single time, right? Because every time you're going to change r to 3 for 1 year, and then to 4 for 1 year, and then for 2 for 1 year. So essentially, in that case, you're just using the percentage increase, the percentage increase equation, okay? So I'm going to go ahead and solve this. So for the first year, we're going to find the new amount of money I have, which is going to be the principal amount of money, 1 plus r over 100. And so for the first year, the new amount will be, it will be the principal, which is 5,000 multiplied by 1 plus 3 over 100. All right, so 5,000 multiplied by 1 plus 3 over 100. So for the first year, at the end of the first year, you will have 5,150. Okay, this is the first year. Now, if we go into the second year, we will be increasing by 4%, okay, in the second year. So again, we're going to use the same rule. So new is equal to principal multiplied by 1 plus r over 100. However, what's going to be different here is that new is going to be equal. The principal amount will be the amount from the first year, right? The final amount from the first year. So we're going to put 5,150 multiplied by 1 plus 4 over 100. And I'm going to go ahead and plug this on the calculator. And we get that the new amount is 5,356. Okay. Now, so this is the amount of money you have in the second year. Now, finally, in the third year, it's going to do the same thing, except we're going to increase by 2%. So the new will be equal to P, the principal multiplied by 1 plus R over 100. And so the new amount will be the principal. It will be the final amount from the second year, okay? It's really important to understand how to basically carry what you last use into the next one. So this percentage right here is 2 over 100. All right, so I'm gonna again go ahead and plug this on the calculator. And we get that the final amount is 5,463.12, okay? So basically we gained 463.12 in interest. Okay, so this is the final amount after 3 years, okay? That's it. This is right here. Now, we're being asked, how does this compare to a fixed 3.5% compound interest for the entire period? So if you want to know how does this compare, we're going to go ahead and find the amount I would have if I invested for 3 years. So n is equal to 3. Compound interest at a rate of 3.5. So r is equal to 3.5. And the principal amount I'm investing is stated at the beginning of the question, which is 5,000. Okay, so let's see what compound interest at this rate will give me. So amount is equal to the principal amount multiplied by 1 plus r over 100. to the power of n. And so the amount is 5,000 multiplied by 1 plus 3.5 over 100 to the power of 3. Now I'm going to go ahead and write these numbers down on my calculator. And we get 5,543.589 and a bunch of more decimals. Okay. So as you can see, with compound interest at this rate, we actually get more money. We would have to a higher total amount of money at the end. So how does it compare? We can just write down that using compound interest yields more money at the end of the 3 years. Okay. Okay, so now let's take a look at the final question. So you have $10,000 to invest and are considering 2 different investment options. Bank A offers a compound interest at 1.5% per year. Okay, this is simple. And Bank B offers a 3% interest added after 3 years. Okay, so the wording here is a little tricky. We will deal with this in a second. Calculate the total value of the investment under each option after 3 years. Which option will give you more money? Okay, so again, we're going to go ahead and firstly find Bank A. What will my investment be worth after 3 years? Okay, so in order to find that, we're going to go ahead and write down what we know. So we know the principal amount I'm investing is 10,000 and the rate is 1.5 and I'm going to be investing for 3 years. Using this information, we can simply find the new amount. So the new or the final, I think the rule says final or like the final amount. By the way, it doesn't matter what letters you use, really. You know, as long as you understand, the examiner does not care about what letters you use, okay? As long as you understand that this will be the final amount, you're good to go. You can use any letters you want, really. Anything that makes you understand, you know, this is the final amount. You can put F for all I care. It doesn't matter, okay? So the amount will be the principal multiplied by 1 plus r over 100 to the power of n. And so the amount will be equal to 10,000 multiplied by 1 plus 1.5 over 100 all to the power of 3. So we're going to go ahead and write those down, add them on the calculator. And we get that the amount after 3 years, the final amount is 10,456. I'm just gonna do this to the nearest dollars. 10,457. Okay. So this is the final amount after 3 years with Bank A. Now let's take a look at how Bank B works. Now you need to understand, this says 3% interest added after 3 years. Okay. So basically, you have $10,000, okay? This is during year 0, okay? Now, in year 1, at the end of year 1, you will have the exact same money, 10,000. In year 2, you will also have the exact same amount of money. You won't gain anything. However, in year 3, you will have 3% interest added, and that will be the new or the final amount of money you have. Okay, so this is what the wording here can be a little tricky. So it's added after 3 years. So right here you will have nothing. After 3 years, at the end of the 3 years, this is where you will get 3%. Okay, so in order to find the final amount, it's really easy. You can just use this is a percentage increase, really. We're just going to increase our money by 3%. Okay, so the new or the final amount of money will be the principal or the original. Okay, again, it really doesn't matter what letters you use. The original multiplied by 1 plus r over 100. And so the new amount of money is 10,000 multiplied by 1 plus 3 over 100. And you plug this number on the calculator, you should get 10,300. Okay, this is your final amount after 3 years. This is in bank B. And by the way, you don't need to do this whole process. I mean, if you just find what 3% of 10,000 is, it's 300. So all you have to do is add those 10,000 plus 10 plus 300 will give you 10,300. Okay. So this is an equally valid method, but some students are more confident in or feel more safe in using a rule that you can just plug in the numbers. So this is the rule right there. Okay. So hopefully this is well understood now. So at the end of 3 years for bank B, this is the amount. At the end of 3 years for bank A, this is the amount. So which option will give you more money after 3 years? Obviously, it's bank A. So bank A gives you more money. All right. So that's it for the mixed applications of compound, simple interest, and appreciation and depreciation. As you can see, we even dealt with some percentage increase or decrease in these questions. Now you should, if you were able to solve everything here or like understand all the questions, you should be more confident at solving any question that you come by on these topics. Thank you for watching.